everyone. This is our first UNICOM talk for fall of 2020. And of course, we are now kind of moving into where, like a lot of things, we're doing this online and virtual. We're pleased to have Dr. Alan Tribble, who is with us from Collins Aerospace over in Cedar Rapids. That's going to lead our talk today that will talk on business management for engineers. So his presentation will go through business skills, and it'll talk about the value technical professionals bring to the employers, business of business, stock markets, business models, planning for success, and evaluating success. Dr. Tribble is the author of the book Business Management for Engineers, which the Journal of the Society for Technical Communication said should be required reading for all engineers, and I would agree with that. Dr. Tribble started his career as a space environment effects specialist for Boeing Space Systems Division in Southern California. He is currently a program manager in the Research and Emerging Technologies Organization for Collins Aerospace in Cedar Rapids, Iowa. In the past 20 years at Collins, he has held a number of diverse positions in engineering management, business development, and product line management. He holds a BS in physics from the University of Arkansas and an MS and Ph.D. in physics from the University of Iowa. So with that, I would like to give a warm welcome to Dr. Alan Tribble. And with that, go ahead and get started.
Well, thank you very much for that nice introduction, Dr. Nelson. It's always a pleasure for me to have the opportunity to share with Iowa State. Obviously, we'd prefer to do this face-to-face, but are adjusting to the new normal for information sharing, and I'm sure we'll do a fine job via this remote presentation. As Dr. Nelson said, I have a very strong technical background in aerospace. I worked on spacecraft for a number of years, now work more on the aircraft side. But it really is a shock to me in many ways to think about me doing a talk on business management, knowing that as I was going to school and in the early years of my career, I thought I'd be happy being a nerdy rocket scientist. But people evolve, careers evolve. I'm now very happy being on the business management side. I do know that early in my career, as I looked at people who had moved from engineering into business development or program management, what would motivate them to do that? And as a student of engineering, you may wonder how such a radical transition could indeed happen. So let me first off just share you my thoughts on that. And my conclusion from a couple of decades in the industry is shown here. I believe that the most respected technical professionals are the ones that can spend a week in a room full of PhDs studying very complex technical issues and then walk into the CEO's office and explain what all the technical analysis means to the business. And so at Collins Aerospace, we have elevated a few of our technical experts to the rank of technical fellows. And when I work with them, they clearly understand both sides of that equation. They understand the technology and are a corporate expert, in many cases, national experts in their technical field. But they also understand the business side or the business aspect of that as well. And I use that term business aspect deliberately. If you look around at many of the engineering standards, and in this case, I'm citing one from INCOSE, the International Council on Systems Engineering, when they note in their documentation that every system or product lifecycle has not only a business aspect, but also a business case behind that and a budget aspect. Now, if I had one bit of helpful advice for INCOSE, it's I would broaden that last statement to be a budget and a schedule aspect, because all three of those things go together. When you're working on a new technology or a new technical innovation, there is almost certainly a business case behind that. There's a reason for doing it. And behind that business case are certain assumptions about the budget that you have available and the schedule or time that you have available. And if you violate any of those constraints, the business case starts to fall apart. So what I want to share with you for the next few minutes are five of my key takeaways about business and how technology and technology professionals can benefit from an understanding of some basic business principles. And so, first off, I'm going to give you a quick quiz. When presenting to an academic organization, got to give you a little quiz to make sure you're engaged. Don't bother raising your hands. We're all working remotely. I can't see that. But think about the following two questions. How would you fill in the blank to the question, engineering is the application of science to develop new products and services that are, you pick the word. And again, the second question, business is the application of economics to develop new products and services that are what? So let me give you just a couple of seconds to think about that. And then I will share my answer with you. All right. Well, my answer, and again, there's no clearly defendable best answer here, but my answer, engineering, the application of science to develop new products and services that are useful. In business, it's the application of economics to develop new products and services that are profitable. And I would argue that you cannot have a successful product unless you address both of those topics. If you design something that's useful but not profitable, you're going to lose money, and you're not going to be able to stay in business. You're not going to be able to continue to offer that product or that service, and so it will fall out of the marketplace. At the same time, you can have a very profitable product, but if it's not useful, if it doesn't help some customer solve some problem they have, nobody's going to buy it. So again, you're not going to have the ability to stay in business. So I think that we have to address both of those. And so when we think about what it takes to start with a good technical idea and move that from concept to reality, we can go back to Adam Smith. He's often called the father of economics. Back in 1776, he wrote a book called The Wealth of Nations, and he noted that to make things happen, to bring ideas to reality, you need three things, and he called them land, or raw materials, as we might call them today, labor, and capital, or money. But that term capital is means money in this context, and that's where capitalism gets its name. We also, at the bottom of this, say that's how the great entrepreneurs make things happen. They start with a great idea, and eventually they're able to leverage raw materials, labor, and some capital into a great idea. And I'll point out Jeff Bezos and Elon Musk, for example. Jeff Bezos, who founded Amazon, is bankrolling Blue Origin, who is developing reusable launch vehicles. Elon Musk doing a similar thing with SpaceX. Both of those companies are trying to radically change the cost of space exploration by making it possible to reuse launch vehicles. Not even something that we could conceive of doing just a couple of decades ago, but now we're doing it regularly. Similarly, you look at other great entrepreneurs like Bill Gates or Steve Jobs. They have some great ideas, but are able to leverage those into very successful businesses by understanding some of the principles there. So I'm going to make 5 recommendations for you, and the first recommendation I would have is shown here, and it's really understand the business of business, or if you want to think of it, the business that you're in. If we're an aerospace engineer, we may wind up working for an aircraft or a spacecraft manufacturer. If we're depending on the job that we get, we may work in a very different industry, but there's a business case for that industry and for that company, and it helps if we understand some of the basics there. For example, I work for Collins Aerospace in Cedar Rapids. We are now part of a larger organization called Raytheon Technologies, and you can go look up Raytheon Technologies stock on the stock market and figure out what it's selling for. But that stock price is a very crisp metric that we could all look at to gauge the health of the company. In the United States, we tend to think of the New York Stock Exchange or the NASDAQ, but there are hundreds plus stock markets out there in the world, and on many of those markets, different companies get bought and sold, and that value of the stock is determined by the people who want to buy it. And so if you're a public company, you're very concerned about stock price. And if you work for academia or government, you're probably not so concerned about stock, but you're going to want to look at the source of your funding, which could be indirectly from the taxpayer. And so making sure you understand where that cash comes from is very helpful. Some of the basic principles that support that idea are things like accounting. And there's some basic ideas. Obviously, we could go over to the accounting department and take classes on that. But there's some basic terms that the accountants use, like orders, sales, expenses, and so forth, that it helps to make sure that we understand as engineers. They mean subtly different things, and just making sure that we understand what they mean and how they're used, why they're important to our organization is very helpful. At the same time, I think that understanding the business model for the product that you are working on is very helpful. How are we going to make money? And I'll give you an example of that in just a bit. And last but not least, things like value propositions. Understanding, why do people buy our product or service and not somebody else's? That's important. And as that last sub-bullet says there, don't forget that employees have value propositions in the eyes of their employers. So understanding the value proposition you bring to an employer when you're applying for a new job is again, some insight that will help you be better prepared for that interview, be better prepared for job prospects. Well, just there's a lot of information in this chart here, and I'm not gonna go through the gory details, but I just want to use this figure to illustrate the fact that it's often a balancing act when you're managing a company. You got customers on the left that want lower prices so they can afford to buy more and use their money on other things. At the same time, you have some owners on the right who want higher profits. And if we lower our prices too much to make our customers happy, owners get upset. If we drive our profits up to make the owners happy, customers get upset. So continually, the executive leadership of a company has to balance all of these factors. And it starts on the top left with the thing in blue there called the orders. And so we get an order from a customer, we deliver them a product or service, and they give us some cash. We make a sale. And so from an accounting perspective, there's a timing difference there. And I always give the example of going out to dinner, or at least I should say, I used to use the example. I haven't been out to eat dinner in 6+ months here, but if you can imagine what that used to be like, we go out to a restaurant, you look at the menu, you'd place an order with a waiter for a dinner. They go off in the kitchen, cook it for you. Sometime later, they bring it out, serve it to you. You would eat it, and then at that point, you would pay your bill and leave. And so that instant in time where you pay your bill is the sale. So there's a lag between orders and sales. For a dinner, that lag might be an hour. For an aircraft or a spacecraft, that lag could be months or years. And so we need to understand how those metrics are used and how they're a little different. All that other detail on the bottom just goes into some of the accounting things that you start with your sales, but you take off your expenses, the cost of goods sold, for example. And what's left is profit. And so that basic relationship of profit is sales minus expenses, something we can all wrap our heads around. But that's what we're going to be judged by a lot at the end of the day. How profitable is this business? And those are the kind of things, again, that executives do with a company. And we need to appreciate that when the executives make some changes to cut expenses, if revenue drops, that they need to do that to keep the ownership of the company happy. At the same time, if revenue grows Now there's an opportunity to expand. I have more cash on hand that I can reinvest into my business and use that investment to grow in other areas, buy different test equipment, buy new capital equipment that can allow me to do other things or do them better, cheaper, faster, and so forth. So I talked about business models. Let me give you just a very simplistic example of what I mean by business models. And this is one that I think most of us can relate to. We don't always think about what a business model is, but here's a good example, I think, of one for inkjet printers. So I've got an inkjet printer sitting on my desk here. Went into one of the stores a year or so back and said, okay, well, I can buy a new inkjet printer, and inside of that printer are 2 print cartridges, and I can get that for $59.99. So let's call it $60, okay? And when those cartridges run out of ink, and they're pretty small, they will run out of ink eventually, then I've got this printer. It doesn't do me any good to buy a different print cartridge. It won't fit in the printer that I have. I don't want to go through the expense of buying a completely new printer. I just need a cartridge. So I'm going to go back to the same store and purchase a new cartridge, but now they're going to charge me $20.99 a piece for those cartridges. Okay, well, do the math, and you might conclude that, oh, well, the printer is cheaper than the inkjet, but I think that's just part of their business model. Their business model is going to say, let's get into this business knowing that we're going to sell the printer at cost and not worry about making money off of that, but we're going to generate more profitable but more consistent stream of revenue for years to come with ongoing sales of those print cartridges. And so there's a way of getting a long-term revenue stream at a higher rate of profit if I convince the person to buy my printer at a very low cost. And so that's an example of a business model. Business models for aircraft or spacecraft are going to be noticeably different, but hopefully you can understand the example there. And things that inventive entrepreneurs do is they find ways to disrupt traditional business models and upset the marketplace. Good example is Jeff Bezos with Amazon. Back in the day, you had to physically walk in a store. He says, hey, with the internet, no need to do that. You can just sit at the comfort of your desk, place an order online, wait a bit, and things will show up on your doorstep. So that's a disruptive business model in that sense. Lastly, just want to talk here for briefly about value propositions. And it is important whenever you're working on a product to understand why your customers buy it. And yes, technology is cool and exciting in its own right, but at the end of the day, there's probably a reason why someone buys that that's more than it's just cool or exciting. There's a problem they're trying to solve. And if you understand how your product or service solves your customers' problems, and you can articulate why they should buy it from you versus your competitors, why your solution does a better job of solving their problem than anybody else's, then you're in a great position to do a lot of business, secure that business, and make some great inroads to that market going forward. No matter how good your technical solution is, if it can't help the customer solve a problem they acknowledge they have, they're really not going to care. All right, well, transition to my second point here, which is I understand the organization, and I'll give you a little example here. I hear people like Collins joke about this from time to time, so I'll just repeat that joke here. If you don't work at college, you may not have heard it, but one of the jokes that we make in the engineering organization is that we have 2 kinds of employees. We have engineers, and then we have those who wish they were. And so engineers can easily chuckle at that. That's a nice way for us to look at the world. But there's a little bit of an accurate reflection there, I think, of how engineers view the world. For example, when we look around, we see other engineers, and we appreciate that there's a difference between aerospace engineers and electrical engineers, mechanical engineers and industrial engineers, and so forth. There's a difference between software, firmware, and hardware. Okay, and so we know the difference, and so we appreciate that. All right, close this down. But then we just look and say, well, everybody else in the company is a non-engineer, and that definition works great for most of us when we're in entry-level positions. We probably don't interact much in our early professional careers with non-engineers, but when you look around, we realize there's a lot of other parts of the company there. And so, for example, here's just an example of the type of organizations you would find in a large company like Collins, or even a large government organization like NASA or the FAA, or what have you. Most of us with a degree in engineering wind up in that top bucket on the top left there, wind up in what they would call the engineering organization, or the design organization, where we're going to design new products. Some of the engineers move into the production organization, where we're going to build and test products, for example. And over time, people like me migrate into other roles, program management or business development. But there's all this other stuff underneath that you have to manage a business. For example, contracts and subcontracts. Okay. New engineer, it took me years to appreciate that they were even different and why they were different. But they are subtly different parts of the organization. Contracts organization receives orders from our customers. Subcontracts gives orders to our suppliers. And so knowing when you need one or the other helps make you more effective. And so, again, those other parts are there for a reason. Just encourage you to know in your career when you need to reach out to them and who you need to reach out to. Again, will make you a lot more effective. All right, well, number 3. I want to encourage you to understand the rules of the road. And we're in the United States here, so I'm talking specifically about U.S. laws and regulations. They influence how you do business. Now, I'm not suggesting that we all go off to law school and get degrees in law, but there is a viable career option for people with degrees in engineering, and that's to go become a patent attorney and manage things like the intellectual property of our company, the patents that we have, and so forth. And there's some differences here between our attitude in industry and the attitude that I perceive there is in academia. I'm not an academic, so but when I was in graduate school, the attitude was, I want to write a new paper and tell the world. Every time I learn something new, I want to write a paper about it, publish it in a journal, give a presentation at a conference, and tell the world. Because my resume in academia is in part just judged by how many papers, how many presentations I get. Well, in industry, if we figure out a better way to do something, for example, we have Collins and we have internal research and development groups. If they figure out how to do something that's better than the competition, I don't want my competition to know. So I'm not motivated to go to a conference and tell them, hey, I figured out a new way to do things. Now they'll know, they'll start working to try to counter that. But I do want my customers to know. And so I might want to share that information with my customers directly, but at the same time, not tell my competition, and then go ahead and file a patent on it, so that if I have a patent on that, I have some protection. Other people cannot sell a product that contains technology I've patented unless they pay me a license fee. And so that's, I think, a good example of how laws and regulations interact with technology is your intellectual property concerns. And separately, there are things called the Federal Acquisition Regulation System, or just the FAR. That tells the citizens how our government can and will buy things. They can't just give Collins a contract for $1 million because they want to. They have to follow a very well-defined process and make sure that other companies have an opportunity to bid on that effort, so that the taxpayer at the end of the day gets the best value for their dollars. And so understanding that process and understanding that part of that process is making sure that funding is approved and in the budget. And we're coming up, it's the middle of September here. In two weeks, we have the end of the fiscal year. Things have been, if the budget for a New Start program is supposed to start in October, but the budget isn't approved, well, they can't start that program. That's what they go to a continuing resolution. So there's some subtle things in there that we also have to be aware of. After you start working in the United States, it's natural to think, well, I'd like to expand my market. I want to start working internationally, increase my sales by working with other customers other than just those in the United States. So how we do that is controlled in part by the U.S. export regulations. You may have heard of things like the International Traffic in Arms Regulations, or ITAR, that specify, or I should say that place some constraints on what I can export. And in some cases, I may have to go get a license to export that. I have to get the Department of State to approve that, yeah, you can sell that solution to Canada. There are our good friends. We share a border. We share more technology with them than we do most other countries. Yeah, you can export that solution to Canada, but they might not be so understanding if I go in and request to submit that same technology to North Korea or Libya or China, where we're not on such good relations with all the time. And getting out of the United States is half of it. I still have to get into the other company. I have to know how their import regulations are going to affect me. Crazy thing, but when you go do business in other places, they tend to want to pay you in their currency. They don't want to pay you in the US dollars. And so that makes things a little more complicated. And we have to be aware of how currency exchange rates could erode my business case, for example. And last but not least, there are cultural differences. People tell us that we Americans are very direct communicators. If you ask me, Alan, I need to take delivery of that product by the 15th of November. Can you meet that? I will give you a very direct answer to that question. I will tell you, yes, I can, or no, I can't. Other cultures don't like to use that word no, because they've been told no, it's impolite. Don't do that. Don't use that direct terminology like that. So you have to understand that the culture that you're in, and adapt to that. It's the customer, they get to define the rules and regulations, and just be aware that it does change when you look internationally. Well, number 4, know how to plan for success. And I know some of you are going to go to grad school, maybe you're in graduate school already. I would suggest this chart is a good chart to wrap your head around when you're thinking about a topic for your graduate research, for your dissertation, research project, and so forth. But I call them here the Heilmeyer questions. Heilmeyer was one of the early directors of DARPA. Pardon me. DARPA is the Defense Advanced Research Project Agency. Today, they do a lot of funding for research and development. And he started this agency 30, 40 years ago, I think. But his message was clear. Yeah, we're going to be a great source for funding great ideas, great technology development, but don't waste my time unless you can get answers to these kind of questions. First and foremost, what are you trying to do? And when you do that, don't use a lot of technical mumbo jumbo that nobody other than a Ph.D. can understand. Give me words that a 12-year-old can understand. Not because we don't care about the technical details, but at his level, I may go called into a congressman or a senator's office and have to explain what we're doing. I need to be able to do that, explain that to non-technical professionals. So let's make sure that we can understand what we're doing in non-technical terms. And I won't read all of these to you, but other things on the list. How's it done today? You want to do something different? Help me understand why it can't be done today. and why this new approach you're suggesting will overcome the limitations of the current practice. Have we developed a new technology or a new manufacturing process that will allow us to do things this year that I couldn't do last year? And if we get there, who cares? What's the difference it's going to make? Who really needs to know about this? And then last but not least there's risk. We've never done this before, so it's got to be risky. What are they? How much is it going to cost? How much is it going to take in terms of schedule? And how do I know if I'm making progress? What are those midterm and final exams? So great food for thought there as you're looking for how to plan out a project, be it a research project in school or a new development project in industry. And I would tell you that one other reference I'll give to another organization. This is to the Project Management Institute. They issue things like this: the Project Management Project Management Body of Knowledge, or PMBOK. That's recognized by organizations like INCOSE and IEEE and a lot of other technical professionals as this is the standard that we should use for project engineering or program management. I use those terms a little interchangeably there. And on the right are the list of all the topics that they say successful projects have to manage. You have to think about them and think about what the limitations are, what the assumptions are, what the constraints are, and go back to them proactively, regularly, monitor them and control them. And so just to talk to the first couple there is scope. What is the scope of the project that we're committing to? You may have heard the term scope creep. Great way for projects to get into trouble is to allow that boundary between the work you're committed to doing and the work that you're not going to do. If we allow that boundary to grow, I wind up spending time and energy and money on things that I am not supposed to be doing. So for me as a program manager, when someone comes to me and says, "Hey, Alan, I got a great idea. I'd like to change the software implementation, the firmware implementation to add in this new feature. It's going to have a lot of benefits. What do you think?" Okay. Most of the time, my answer to that question is no, because that's how I control scope creep, by not allowing that boundary to grow. In some cases, they come and say, "Hey, we got a problem. Our assumptions about how easy or difficult it was going to be to integrate this solution didn't work out. I need more money." Okay. That's not scope creep. That's just a reality that I got a budget problem. So yeah, okay, we can add money to things like that. But we also have to look at time or schedule and cost, the budget, the quality that's expected. And that's one of the differences or the challenges in getting things to move from academia. For example, if you may be working on a fantastic concept at Iowa State as part of your research project, and you develop a new way to do things, and with an army of graduate students and years of training, you can get a project or technology to work in the lab. That's very different than getting it to work repeatably in a factory on a production line. And so how do we make sure we get the quality addressed and so forth? So all of those are things that successful projects have to plan for to make sure there are no surprises as they start executing. And then finally, the last topic I would share with you is make sure that you know how success is going to be measured. And as I say here, there's a difference between technical success and business success. Meeting the requirements, those technical performance metrics, isn't enough. That's the price of admission in a sense. If we get a contract to design a new radio, for example, there's probably going to be a requirements document there that says, okay, here's the 100 things that radio has to do at the end of the day. I can meet every one of those metrics and still not succeed if I don't pay attention to the business aspect as well. So for example here, and I did a quick internet search the other day, And I found this list. Time magazine listed out 20 of the most successful business failures, and I listed 10 of those for you here. Many of these, if you're a student, many of these were before your time, and you may not recognize them. I know Betamax, for example, that was, about the time I was a student 30 years ago. That was already fading from the scene. But things like the Segway or Windows 8, may be things that you recognize. Well, these are technologies that are good ideas. They're good improvements. They start to get a little bit of what I call market share, but they never really catch on, or they got some market share, but they didn't keep up. A few years ago, one of the professors at UCLA wrote a book called Collapse, where he studied societies that were great at some point in recorded history, and a decade or two later, they had fallen, and they weren't great anymore. And he found that the common thread they had is that people failed to appreciate that what got them great in the first place would not keep them great long term. We have to appreciate that we've got to adapt. We got to adapt to changing market conditions, to changing technologies. If we don't do that, our solution will fade. And last slide on this topic is, again, know how success is measured by the different parts of the organization and by the different levels in the organization. I used to be what we called an entry-level engineering manager. I had engineers reporting directly to me that were focused on certain technical areas. I reported to an engineering director that had a number of managers in a broader portfolio reporting to him or her. And as you move up levels, or as you move across levels, how success is measured is going to change. By your fellow engineers, if your technical solution works, you're going to get a thumbs up. Hey, good job implementing that code, implementing that firmware, testing that solution. That's the basic metrics of success. But when we start to broaden our horizons and look at things at the program level, for me as a program manager, I'm going to want to know, yeah, you met your technical objectives, that's great, but don't forget the business aspect. Did you meet your cost and schedule metrics? And we use tools like earned value management, EVM, to help measure that. When I go into meetings with my portfolio director who's looking at, hey, I'm offering a number of different products to the marketplace. How's our market share? How much of the possible opportunity to sell radios did we capture last year? Is that market growing? Are people going to start buying more radios in the future or less? And so they'll use other tools. You can do searches for the Boston Consulting Group or the BCG Matrix. It's a very crisp visual way of visualizing where you are in the market. By the time you get up into the business unit or the vice president level, they're going to want to know, how are my margins? How are my profit margins? How's this industry going? And they'll use other metrics to work for that, or to look for success at that. By the time I get to the CEO's office, they're going to be focused on the stock price. All of those things at the top of that list affect the stock price. Are people buying our stock? Is our stock growing? Good day to be CEO. If people are recommending that we sell our stock and our stock price is dropping, not such a good day. And so, again, just a little bit of appreciation of how things change as you move up or across in the organization really helps you adapt your message so that it's well received. Well, that's the main things that I wanted to share with you today. As I said at the beginning, my conclusion after a couple of decades as a hardcore technical professional is that the most valuable engineers are the ones that understand the business impact of technical decisions. And so understanding some of those basic business principles will increase your value proposition in the eyes of your employer. So at that point, I will say thank you very much. I hope you have managed to learn a few things. I will hand it back to Dr. Nelson, and I'll be glad to answer any questions as time permits. And thank you again.
Okay. So yeah, thank you, Alan, so much for all of that. That was really, really helpful. And I think again, for a lot of our students, sometimes the project management and both the business management sometimes gets overlooked. It's very easy to get involved in the engineering side and not think about some of the other aspects that go on, especially in the industry for that. So I do appreciate all of that. So with that, do we have any questions? I don't see anything in the Q&A yet, but does anyone have any questions that they would like to ask? And I forgot to mention this beforehand, I posted something in the chat. Hopefully everyone saw it, but if you could please put those into the Q&A, that way we can read those and pass that information along. And Christine, do you see any with the Q&A?
I don't see any Q&A, and I don't see your message in chat. So.
Oh, okay. Okay. Well, we'll give, maybe if some people are typing out a question, we'll give them a couple minutes. There we go. Okay, so we have one question here. This is from Cole. What are your recommendations for being successful in the aerospace industry when initially getting a job?
Good question, and I will, with a bit tongue-in-cheek, resort to a source of semi-infinite wisdom, the comedian Steve Martin. Someone once asked him, "How do you get a job in comedy?" And he said, simply, "You just have to be so good they can't ignore you." And so that's not necessarily the most helpful advice, because then we want to know, well, how good do I have to be, and so forth. But I think that when you're marketing yourself to a new employer, you want to make sure that you have the skill sets that employer is looking for. You want to make sure that your value proposition as an engineer is skill sets that you have, and the type of tasks that you can be successful for are going to help that business, going to help that company attain their goals of delivering whatever products or services they are. And so I would think that just understanding that, showing that you do appreciate that the skills you have are going to help them design the kind of products and services they're offering is a great way to close that gap. And hopefully that gives you a little insight there.
Okay. Any other questions? Just so that everyone does know, again, this is recorded. So once we get this recorded, kind of processed through WebEx and everything like that, we will post this. We'll probably post it on the M2I YouTube channel. And if anyone does have any questions that maybe they think about afterwards, then feel free to email both myself and Christine, and we can always pass that along as well too. Okay, we got another question here from Andrew. What are the ethical considerations when balancing profit versus accessibility? Oh, that's a good one. Yeah, so what are the ethical considerations when balancing profit versus accessibility?
Can you elaborate a bit on what you mean by accessibility? I'm not sure I'm interpreting that term correctly.
We'll give them a second to.
And while you're answering that question, let me give you a little bit of an example about, one reason I believe that companies around the world like to do business with Collins is because we are an ethical company and we don't hesitate to tell the truth even when it hurts. And I will give you one example I'm aware of. We were doing business with an international customer. I'll be a little vague there, but the customer had issued us a list of requirements, and we had analyzed it and concluded basically you can't get them from here. At the end of the day, this violates the laws of physics. There's no way to solve this problem. And so they were in a meeting with the customer trying to explain that, make sure there's not some cultural difference here. There was a language difference. This customer was not did not use English as their primary language, and so we spent a good deal of time trying to make sure that we were actually interpreting the requirement correctly. And when it became obvious that yes, this is the requirement and this is what I want you guys to do, our technical expert said, you can't do it from here. And one of our experts got up in the meeting and said, program manager, this is not a solvable problem. It violates the laws of physics. Here's why. Wrote a couple equations on the board, said, I recommend we no bid this program, sat back down. Now, at a time like that, you think, well, we just lost the business. They're going to go with somebody else. But in this particular case, the customer then powwowed off in the corner and came back to us and said, you're the only company that had enough courage to tell us that. We want to work with you. And so that's a good day for everybody when we get to solutions like that. So absolutely, there's an ethical aspect to all of our engineering programs and that we need to be aware of. But back to the original question, did we get some clarification on that?
Yeah, he posted in there how easy or affordable it is for the consumer to access.
To access? I missed the last word.
Yeah, well, he said how easy or affordable. So I'm thinking maybe as far as accessibility, maybe at price point.
Okay, okay, I think I'm starting to understand. So we're asking, how do I balance the fact that I'd like to make bigger profits with the fact that if I don't, that people who may need my product may not be able to afford it. And so I think that's a very valid concern. In the industry that I'm in, that's not as big an issue because we sell at Collins primarily to government or airlines that can cover their costs. I think that'd be a great question, though, in the context of a topic that's all near and dear to us all these days, and that's a COVID-19 vaccine. If I come up with a COVID-19 vaccine that works, and I'm the only company that does it, you got to come to me for that vaccine. There's no alternative. It would be very tempting to put a significant markup on that medicine and make it a very profitable endeavor for the company. But at the same time, the ethical aspect says don't do that. Make it as affordable as you can so that people who need it have access to it. And I think if we think of it that way, we all appreciate there definitely is an ethical balance there. I don't know if I can give you a crisp answer as to how we do or we should manage that balance, but I think that it does vary by industry, by culture. But that's one of the things that when you're looking for a job as an engineer, assess the culture of the company. Are they committed to that? The company that you're looking to work with, are their values, is their culture in alignment with your personal values? And I think that's the best way to deal with that is work for companies that have the same ethics as you as an individual.
Okay. Any other questions? We probably have time for sure for one more if someone wants to ask one. So I'm not seeing anything yet. And we are pretty good on time. I know Alan, you have something at 4 o'clock. So not So we got one more question. What made you switch? I'm assuming maybe he's talking about maybe the switch between like going into more like a management type of position.
Yeah, no, good question. In my personal case, I was just ready for a new challenge. I spent the first roughly decade of my career out of graduate school doing what's called space environment effects analysis. I used to, from time to time, go to Iowa State to give lectures on that as part of your spacecraft design curriculum. And I realized after about a decade, I'd pretty much done most of what there was to do in that area. I wrote the first textbook on the subject. I was teaching professional development courses on the subject. A few years later, I actually got the Professional Development Award for that area. And when I looked at what's the next 10 years look like, it was pretty much going to be a repeat of things that I'd already done and knew how to do well. And I decided that I was ready for a different challenge. That's a big part of that. Part of that, quite frankly, was that I was living in Southern California at the time, and which is an exciting place to be if you're single, and there aren't wildfires degrading the air quality. But when you are from the Midwest and you're married and have children, you start looking back at the Midwest lifestyle and realize, wow, there's a lot of advantages there. And that combination of wanting a new challenge and wanting to make a physical change in locations led me just to look outside of engineering. And I would tell you, I've not regretted that. I have worked in engineering at Collins Aerospace here in Cedar Rapids. That was certainly enjoyable and challenging in its own right. But once I made the move to business development and program management, I have absolutely no regrets about doing that.
Okay, and we got one more question. This might be a good follow-up to that one as well. So what was the transition process like for you when moving from engineering to business?
Yeah, good question. And that's one of the pieces of advice. If you're looking at making a career change, let people know. I think that's one of the things. I can think about it in my own mind, but if I don't ever tell anybody else, they can't help me make that transition. So part of it was I just started looking for opportunities to move more into a management role. I first moved to an engineering manager position, and what we call a technical project manager. It's think of it as a chief engineer, lead engineer role. So I was leading the engineering team, and so it wasn't that big of a step to move from leading the engineering team, which is where most of the people are, into just leading the team as a whole, which involves the other parts of the organization. So I just let people know I'm interested in those kind of opportunities, and got a couple of pointers to people who are hiring for new opportunities that they thought might be a good match to my skill set. And eventually I found an opportunity to move into a business development role. And as I said, I've got absolutely no regrets about doing that.
Okay. We'll just, oh wait, actually. Yes. One more question. As both an engineer and as a business leader, what do you think of the difference in solution development approaches of, let's say, SpaceX versus Blue Origin, i.e. rapid prototype and failing often versus longer development process but less failures?
That's a good question, and that's probably a whole hour-long discussion there as well. I think there certainly is a lot to be said for rapid development. You hear people use the term fail fast. Elon Musk is very big for saying, I don't care if we fail as long as we learn something from it, because the more we learn, the more likely we're going to be to succeed next time. Jeff Bezos may be taking a little more risk-averse approach with Blue Origin, but I think they both have very viable solutions in the marketplace, and over time, I think we're just going to see how those approaches flush out. Is one organization going to win more business than the other? That may give us insight as to which of those approaches ultimately are more successful. I know Blue Origin's won a really large, I think it was $500 million contract from NASA. And SpaceX has won their fair share of of launch contracts as well. So I think we'll just have to wait a bit and see if history judges one of those approaches to be better than the other in the long term.
Okay. Okay, let's see if there's going to be one last question. If not, I think this will probably be a good place to stop. And I'm not seeing anything. So, with that, again, Alan, thank you so much for joining us today. Very much appreciate the talk. We'll definitely have to have you when we can maybe have some stuff face to face. We'll have to come and have you visit sometime. And again, thank you so much for everything.
You're very welcome, and yeah, would very much look forward to visiting Iowa State again whenever the pandemic recedes a bit. Thank you again for the opportunity.
All right, thank you again, and thank you everyone who came for this afternoon. Again, we'll let everyone know when we get this posted, and we'll go from there. So with that, we'll go ahead and conclude this talk. Thank you, everyone.